In this video, we'll be looking at the pitch profiles available on the C100 Mark II and how they might influence your chosen exposure level. The only variable that changes between these tests is the amount of light in the scene, as the aperture, shutter speed and ISO have remained consistent throughout this experiment. When testing these pitch profiles at different exposure levels, we'll also be concerned with how much information is retrievable with post-production colour correction at different light levels within each profile. Our display setup here is made up of 3 windows. From the left we have our gamma graph. On this we will be able to see our internal gamma profile as recorded by the camera, displayed as an orange line. Where applicable, a blue line will be used to show when post-production colour correction has been applied. Our next window is our output. Here you will be able to see our final shot in full quality as recorded by the camera. The third window is a recording of the C100's LCD screen, displaying all current settings and the waveform. To start, we'll look at normally exposed footage shot without a pitch profile. As you can see on the left, there has been no internal adjustment to the gamma curve. We have a balanced overall exposure of our skin and colour card, with very few specular highlights reaching 100 IRE, and only the deepest shadows falling at 0 IRE. This is our baseline. Next we have the EOS standard profile at regular exposure. On our gamma graph, we can see that this profile is crushing down the low mids and shadows, while simultaneously pushing the higher mids and highlights in the opposite direction. This results in a heavily increased level of contrast within the image. This is reflected in our waveform as our highlights have moved closer to absolute white and our shadows have fallen closer to absolute black. Next we have the wide dynamic range profile at regular exposure. The dynamic range of an image is simply how much of a difference is found between its lightest and darkest regions. The wide DR profile is designed to raise the gamma in the darkest portions of your image while lowering the brighter parts, resulting in an image with less contrast and therefore more scope for adjustments in post-production. Next we have the cinema profile at regular exposure. Similarly to the wide DR profile, cinema is designed to increase your dynamic range, but to the maximum extent of the camera's ability. Shadow detail is harshly raised and highlight roll-off is lowered significantly, resulted in a drop in exposure to the very flat nature of the image, with little contrast. When using this profile you may need to adjust your exposure to compensate for this loss in contrast and luminance. Now we have the same shot in cinema at regular exposure with colour correction applied. We have graded the shot by increasing the contrast to a normalised level, similar to but not as harsh as the EOS standard colour profile. When doing this, we have retained far more detail on the shadow and highlight areas. Now we will look at these pitch profiles when underexposed by one stop. As you can see, when underexposing the C100 without a pitch profile selected, there is an immediate loss of detail in the shadows. This is reflected in the camera's waveform. This loss of detail is more apparent when using the EOS standard profile, as its contrast increase is more severe. The loss of detail is somewhat less when using the wide dynamic range profile, due to its raised blacks, however the noise level in the shadows is increased. This increase of noise follows the same pattern when using the cinema profile. You can see the full extent of the noise when grading these profiles. An example of this is the red blotches you can see here in the jacket shadows. In these next clips you can see the issues extend further the more you underexpose the camera. With no pitch profile applied. In EOS standard. In wide DR. With the cinema profile applied. Graded in the cinema profile. Now we will look at how each profile handles overexposure by one stop. Here we can see how the camera handles pushing the exposure without a pitch profile, with the increased waveform on the right and clipping of some of the specular highlights. With With the increased contrast of the EOS standard profile, the highlights have been severely clipped. Baking this into the image would result in no way to fix this in post-production. When upping the exposure in YDR, we can see a positive result in the shadow detail and very little loss in the highlight specularity. The cinema profile retains the range fully without any loss in highlight detail. When graded, there is little noise in the shadows and gives a balanced image overall. Now we will look at how each profile handles overexposure by 2 stops. With no pitch profile selected, overexposing by 2 stops severely clips the image. In EOS standard, this is exaggerated, with almost full loss of detail in your highlights. In YDR, a significant amount of highlights are now clipping, with the exposure being pushed by 2 stops. However, the rest of the image is well exposed, with little noise in the shadows. In cinema, you can almost retain all the highlight detail, and gives you the most depth in your shadows possible for this camera. When grading footage shot 2 stops over in the cinema profile, we are able to achieve detail in the shadow areas with no noise. The specular highlights in this shot are almost all retained, with a very small portion of the face clipping. With on-set controls, such as flagging our key light, or the addition of makeup on our subject, this detail would be retained. Dependent on the needs of your project, each pitch profile has its own strengths. However, to gain the widest dynamic range possible out of this camera, we would recommend using either the YDR profile or cinema profile. To gain the cleanest image possible when using the cinema profile, we recommend to overexpose your image between 1.5 and 2 stops, or alternatively to overexpose around a stop when using the YDR pitch profile.